So this is a 256 by 512 pixel LED wall that I built. I used a Colorlight HUB75E controller card. And so basically there's 16 panels, and each panel is basically 128 by 64. So that's why there's 16 channels. Each one is for a dedicated panel. Actually, you can kind of see the seams on that a little bit. Now, you might be wondering what we're looking at. Well, this is Rolling Thunder, the NES version, but it's running on this because we're actually just streaming it out over the computer. We've got, so that's our emulator, and that's running at 60 frames a second. And then what you see in the other box, in there, that's what's actually going to the display. So there's a reason why I want to do this, and so it looks great actually. It's basically like a CRT pretty much. Now whether, well, you might be able to argue it's better, but let's just say it's at least as good as a CRT looks. So I'm kind of working on a new project where I'm going to take the analog video output, the composite video output on the NES, and feed it through a 60 megasample per second 8-bit analog to digital converter, and feed it to an FPGA, and then it's going to produce a HUB75E output, which is basically how this display technology works. It uses a bus called HUB75E, and it's essentially just 16-pin ribbon cable. So so I've got the parts right here actually. So the Arduino is the ICE40 UP50 or UP5K, so that means it has 128 kilobytes of internal RAM, which is actually enough for a whole display buffer. And then there's also the analog to digital converter right there, the 9057, and then those are the two 160 megahertz rail-to-rail op amps. So the analog amplifiers. So that's the analog to digital converter, and basically the idea is that there's two op amps, one that's just gonna boost the voltage of the video, because the analog input on the analog to digital requires it to be between 2 volts and 3 volts, so kind of picky there. And then this next one is just essentially just to regenerate the color burst signal, and so it'll actually feed into the FPGA, and during the color burst phase it will sync up the onboard 3.58 color burst oscillator. So yeah, we're gonna see if it works. I'm gonna build this circuit. Obviously this is just the beginning. I kind of don't exactly know for sure if this schematic's going to change, but basically this is pretty much the whole ball of wax at this point.